Grounding electrodes, while providing a path for lightning strikes, have limited effectiveness in mitigating touch potential because of their relatively high impedance. Therefore, the National Electrical Code, or NEC, does not typically require a ground rod specifically for hot tubs. The resistance of a ground rod varies depending on soil conditions and the depth at which the rod is driven. Even under ideal conditions, this resistance can be high enough to limit the rod's effectiveness in reducing touch potential. To effectively minimize touch potential around an outdoor hot tub, consider several supplementary bonding measures. Firstly, bond the hot tub shell to the main service grounding electrode system. This typically involves connecting the hot tub shell to a metal water pipe, if available, using a copper bonding strap. This connection ensures that the hot tub is at the same electrical potential as the surrounding earth. Secondly, bond any nearby metal objects to the ground electrode system. This includes items such as fences, gates, railings, and any other metallic structures within reach of someone using the hot tub. Bonding these objects prevents them from becoming energized in the event of a fault within the hot tub's wiring. Thirdly, avoid wet or conductive surfaces around the hot tub. These conditions can significantly increase the risk of electric shock. To mitigate this, use non-conductive deck materials or install rubber mats around the hot tub to provide an insulating barrier. Fourthly, ensure proper wiring and equipment. The hot tub must be wired strictly in accordance with the National Electrical Code requirements. Critically, all exposed electrical equipment associated with the hot tub must be protected by a ground fault circuit interrupter, or GFCI. These devices quickly interrupt the circuit if they detect a current leakage, significantly reducing the risk of electric shock. There are additional considerations that are very important. Check local codes because some local building codes may have specific requirements mandating a ground rod for outdoor hot tubs. Always consult with local authorities to determine the specific regulations in the area. Understand soil conditions. If the soil around the hot tub is particularly dry or rocky, a ground rod might not provide effective grounding due to the high resistance. Also, explore alternative grounding methods such as buried earth electrodes or chemical grounding rods. By implementing these supplementary bonding measures, the touch potential around an outdoor hot tub can be significantly reduced, enhancing the safety for all users. Equipotential bonding is a critical safety measure designed to minimize voltage differences in and around a hot tub. This is achieved by creating a low impedance path between all metallic parts, ensuring they are at the same electrical potential. Here's a more detailed explanation of equipotential bonding and its components. The purpose is to prevent electrical shock. Equipotential bonding aims to eliminate or significantly reduce voltage gradients that could cause electrical shock hazards. By connecting all metallic parts to a common bonding grid, any fault current is distributed, minimizing the potential difference between accessible metal parts. Metallic components for bonding includes the hot tub shell itself, metal support structures, metal fences or railings near the hot tub, metal water pipes within a specified distance, metal components of electrical equipment such as pump housings and heater enclosures, and any other exposed metal parts within reach of a person using the hot tub. The bonding grid or bonding conductor is a network of conductive wires, typically copper, that connects all the metallic parts together. This grid is connected to the grounding electrode system, which provides a path for fault current to return to the source. The size of the bonding conductor is determined by the National Electrical Code, or NEC, and is based on the size of the overcurrent protection device in the circuit. Typically, a number 8 American wire gauge, or AUG, copper conductor is used for bonding hot tub components. The bonding connection should be made using listed bonding connectors that are suitable for direct burial. These connectors ensure reliable, low-resistance connection between the bonding conductor and the metallic parts. The NEC provides specific guidelines for equipotential bonding of swimming pools and hot tubs in Article 680. These guidelines specify which parts must be bonded, the size of the bonding conductors, and the methods for making bonding connections. To install it properly, firstly, identify all metallic parts that need to be bonded according to the NEC and local codes. This includes the hot tub shell, metal structures, and any nearby metal objects. Secondly, install a bonding grid by running a continuous copper conductor around the perimeter of the hot tub and connecting it to the grounding electrode system. Thirdly, connect each metallic part to the bonding grid using listed bonding connectors. Ensure that all connections are tight and corrosion resistant. Fourthly, bury the bonding conductor at the required depth, typically 6 inches, and cover it with soil or other suitable material. Fifthly, inspect the bonding system to ensure that all connections are properly made and that the bonding conductor is continuous. Test the resistance of the bonding system to verify that it meets the requirements of the NEC. Grounding refers to connecting electrical equipment to the earth to provide a path for fault current to return to the source, while bonding refers to connecting metallic parts together to create an equipotential plane. Both grounding and bonding are essential for electrical safety, but they serve different purposes. Grounding provides a path for fault current, while bonding minimizes voltage differences. Without proper grounding and bonding, the risk of electrical shock is significantly increased. Voltage gradients can develop between metallic parts, creating a potential difference that can cause current to flow through a person who comes into contact with both parts. Regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. Check for corrosion, loose connections, and damage to the bonding conductors. Repair or replace any damaged components promptly. Always consult with a qualified electrician to ensure that the grounding and bonding system is installed and maintained in accordance with the National Electrical Code and local codes. Improper grounding and bonding can create serious electrical hazards. GFCI protection is a critical safety feature for hot tubs. A GFCI is a device that monitors the current flowing in a circuit and quickly interrupts the circuit if it detects a current leakage to ground. Here is a more detailed explanation. A GFCI works by monitoring the current balance between the hot or energized conductor and the neutral conductor. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. If there is a difference of more than a few milliamperes, the GFCI detects this imbalance and quickly trips the circuit, cutting off the power. A GFCI is designed to trip very quickly, typically within 25 milliseconds, to minimize the duration of an electric shock. This rapid response can prevent serious injury or death. The NEC requires GFCI protection for all electrical circuits that supply power to hot tubs. This includes the branch circuit that feeds the hot tub equipment, as well as any receptacles located within a specified distance of the hot tub. GFCI protection is typically provided by a GFCI circuit breaker installed in the electrical panel or a GFCI receptacle installed in a convenient location near the hot tub. To test a GFCI, press the test button on the GFCI device. This should cause the GFCI to trip and cut off power to the circuit. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, or if it trips repeatedly for no apparent reason, it should be replaced by a qualified electrician. GFCI receptacles should be installed in weatherproof enclosures to protect them from moisture and corrosion. The enclosures should be listed for outdoor use and should be installed in accordance with the manufacturer's instructions. GFCI protection is not a substitute for proper grounding and bonding. It is an additional layer of protection that can help to prevent electric shock in the event of a fault. GFCI protection is not foolproof. It is possible for a person to receive an electric shock even if a GFCI is present. However, GFCI protection significantly reduces the risk of serious injury or death. Regular testing of GFCI devices is essential to ensure that they are functioning properly. Testing should be performed at least once a month, or more frequently if recommended by the manufacturer. Educate all users of the hot tub about the importance of GFCI protection and how to test and reset GFCI devices. Post clear instructions near the hot tub. Article 680 of the National Electrical Code, or NEC, covers the requirements for electrical installations in and around swimming pools, hot tubs, and similar aquatic facilities. It provides detailed guidelines for grounding, bonding, GFCI protection, wiring methods, and equipment placement to ensure electrical safety. Article 680 applies to all types of swimming pools, including in-ground, above-ground, and storable pools, as well as hot tubs, spas, and similar recreational water facilities. It covers both permanently installed and portable equipment. Article 680 provides specific requirements for grounding all metal parts of the pool or hot tub structure, including the reinforcing steel in concrete pools, metal fittings, and metal equipment enclosures. It also requires bonding all metal parts together to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. GFCI protection is required for most electrical circuits that supply power to pool or hot tub equipment, as well as receptacles located within a specified distance of the water. Article 680 specifies the types of wiring methods that are permitted for use in and around pools and hot tubs. It also specifies the minimum burial depths for underground wiring and the requirements for protecting wiring from physical damage. Equipment such as pumps, filters, and heaters must be located at a safe distance from the water and must be protected from weather and physical damage. Article 680 provides specific requirements for the placement of receptacles, switches, and lighting fixtures near pools and hot tubs to minimize the risk of electric shock. The NEC is updated every 3 years, so it is important to stay current with the latest edition to ensure compliance with the most up-to-date safety standards. Local codes may have additional requirements that are more stringent than the NEC. Always check with local authorities to determine the specific requirements in the area. Compliance with Article 680 is essential for ensuring the electrical safety of swimming pools, hot tubs, and similar facilities. Failure to comply can result in serious injury or death. Regular inspections and maintenance of electrical systems are necessary to ensure continued compliance with Article 680. A qualified electrician should be consulted for all electrical work related to swimming pools and hot tubs. The purpose of supplementary bonding is to reduce the risk of electric shock by creating a low impedance path between all metal parts in and around a hot tub, ensuring that they are at the same electrical potential. Supplementary bonding is required in addition to the normal grounding and bonding requirements to provide an extra layer of protection against electric shock. Supplementary bonding is required for all metal parts within 5 feet of the inside wall of the hot tub, including metal fences, railings, ladders, and other metal structures. The supplementary bonding conductor must be a solid copper conductor that is at least number 8 American wire gauge, or AUG, in size. The bonding conductor must be connected to all metal parts using listed bonding connectors. The connections must be made in a way that ensures a reliable, low-resistance connection. The bonding conductor must be buried at a depth of at least 6 inches below the surface of the ground. The bonding conductor must be continuous and unbroken. Splices are not permitted. The bonding conductor must be connected to the equipment grounding conductor of the circuit that supplies power to the hot tub. The connection must be made at the electrical panel or at a junction box. Supplementary bonding is not a substitute for proper grounding and GFCI protection. It is an additional layer of protection that can help to prevent electric shock in the event of a fault. Regular inspections of the supplementary bonding system are necessary to ensure that it is in good condition and that all connections are tight and corrosion-free. A qualified electrician should be consulted for all supplementary bonding work. Improper supplementary bonding can create serious electrical hazards. The resistance of a ground rod is influenced by several factors, including soil resistivity, rod depth, rod diameter, and the presence of multiple ground rods. Soil resistivity is the measure of how well the soil conducts electricity. It is affected by factors such as moisture content, temperature, and the presence of salts and minerals. Soil with high moisture content and high salt content will have lower resistivity and will provide better grounding. The depth of the ground rod is also a factor. The deeper the rod is driven into the ground, the lower the resistance will be. This is because the rod will be in contact with more soil and will have a larger surface area for conducting electricity. The diameter of the ground rod also affects its resistance. A larger diameter rod will have a lower resistance than a smaller diameter rod. This is because the larger rod will have a larger surface area for conducting electricity. Multiple ground rods can be used to reduce the overall resistance of the grounding system. When multiple rods are used, they should be spaced at least twice the length of the rod apart. The resistance of a ground rod can be measured using a ground resistance tester. This is a specialized instrument that injects a current into the ground and measures the voltage drop. The resistance is then calculated using Ohm's law. The NEC requires that the resistance of a single ground rod be 25 ohms or less. If the resistance is greater than 25 ohms, a second ground rod must be installed. The resistance of the grounding system should be checked periodically to ensure that it is still within acceptable limits. The resistance can increase over time due to corrosion, changes in soil conditions, or damage to the ground rod. It is important to use qualified personnel to install and test ground rods. Improperly installed ground rods can be ineffective and can create a safety hazard. Consider alternative grounding methods in areas with high soil resistivity. These methods include using multiple ground rods, chemical ground rods, or ground plates. Always comply with all applicable codes and standards when installing ground rods. This will help to ensure that the grounding system is safe and effective.